So now we're going to talk about what is relative mechanics. Now what is relative mechanics? We have studied about this is not a relative mechanics, I'm sorry, this is relative mechanics. So what is the study of object that travels with the speed of light, right? This is originated from the word theory of relativity. So any object that travels with the speed of light, if you study the relative mechanics, that comes in a modern physics, right? Now what is frame of reference? Frame of reference is a three coordinate axis, right? 1, 2, and 3 are coordinate axis. Now, what is frame of reference? When we talk about modern physics, we are mostly concerned with the frame of references. Now, what is, let's for instance, considering a frame of reference, this is x, y, z coordinate axis, right? This is x, this is y, and this is z coordinate axis. So here, the frame of reference is a ground reference through which you actually fix the position to relative to it, and you count or just measure your changing in environment with respect to it. Right? For instance, this is a car, and this is my relative position for a while. Trace round of reference. And according to this car, I'm moving. For instance, the car is in rest. So I'm moving, right? Rest. When I'm moving, I observe that this car is in rest, right? And I observe that this car is in rest. And when someone sits in this car and just look at me, so according to that person, I'm in motion. So that's the reference you have created. This is a reference point, right? Reference point through which you're measuring your state of motion, state of reference, yeah, state of your body state reference. And here you are measuring your reference point, right? So this is frame of reference. Now talking about a frame of reference, before moving ahead, we discuss about theory of relativity or special relativity mechanics. Let's talk about relativity mechanics, relative mechanics, and I'm going to discuss about few points there as well. Relative mechanics. Now talking about the relative mechanics. Relative mechanics. When we talk about relative mechanics, we basically talk about two frames. We talk about inertial frame of reference, inertial frame of reference, and non-inertial frame of reference. Inertial frame of reference. Now, what is inertial? When we talk about inertial frame of reference, when we talk about inertial frame of reference, we are mostly concerned when the frame either move with uniform velocity or it is in rest or it is in rest. When either it moves with uniform velocity and it is rest, it is inertial frame of reference. And it follows Newtonian laws. Newtonian law. It follows Newtonian law. We know that the Newton physics or classical physics is all based upon Newton's law, right? So Newtonian physics, right? It follows Newtonian physics. But if we talk about inertial, non-inertial frame of reference, which means the accelerated frame, right? This is accelerated frame. It does not follow Newtonian physics or Newtonian laws. It does not follow Newtonian law. It does not follow Newton's laws. So this is inertial and non-inertial frame of references. Now we're going to talk about the theory of relativity or special postulates of a theory which has three consequences and two problems, right? So we're going to